Quantitative methods and statistics encompass a range of mathematical and analytical techniques used to analyze and interpret data. This field is crucial in various disciplines, including economics, psychology, sociology, and natural sciences. It involves collecting, organizing, and summarizing data to make informed decisions and predictions. Topics include data types, measurement scales, and the importance of statistical thinking in research and decision-making processes. Descriptive statistics involve methods for summarizing and describing the features of a dataset. Measures of central tendency, such as mean, median, and mode, provide insights into the typical or average value of a variable. Measures of variability, including range, variance, and standard deviation, quantify the spread or dispersion of data points around the central tendency. Descriptive statistics are essential for understanding the distribution of data and identifying patterns or trends. Inferential statistics allows researchers to draw conclusions or make inferences about a population based on a sample of data. Hypothesis testing involves formulating and testing hypotheses about population parameters using sample statistics. Common techniques include t-tests, chi-square tests, and analysis of variance, ANOVA. Confidence intervals provide estimates of the range within which the true population parameter is likely to lie. Inferential statistics help researchers make reliable predictions and generalizations from sample data to the broader population. Probability distributions describe the likelihood of different outcomes occurring in a random experiment. The normal distribution, often referred to as the bell curve, is characterized by a symmetric, bell-shaped curve and is commonly used to model continuous variables in natural phenomena. The binomial distribution describes the probability of a fixed number of successes in a fixed number of independent trials. The Poisson distribution models the number of events occurring in a fixed interval of time or space, such as the number of calls received by a call center in an hour. Sampling techniques involve selecting a subset of individuals or objects from a larger population to gather data more efficiently. Random sampling, stratified sampling, and cluster sampling are common methods used to ensure representative samples. Sampling distributions describe the distribution of a sample statistic, such as the sample mean or proportion, across multiple random samples from the same population. Central limit theorem states that the sampling distribution of the sample mean approaches a normal distribution as the sample size increases, regardless of the shape of the population distribution. Correlation analysis examines the relationship between two or more variables and measures the strength and direction of their association. The correlation coefficient, typically denoted by R, quantifies the degree of linear relationship between variables, ranging from -1 to +1. Regression analysis explores the relationship between a dependent variable and one or more independent variables. Simple linear regression models the relationship between two variables using a straight line, while multiple linear regression incorporates multiple predictors. Regression analysis helps predict the value of the dependent variable based on the values of the independent variables. Experimental design involves planning and conducting controlled experiments to investigate the effects of one or more independent variables on a dependent variable. Key concepts include randomization, replication, and control of extraneous variables to ensure valid and reliable results. Analysis of variance, ANOVA, is a statistical technique used to compare means across multiple groups or treatments. It partitions the total variation in the data into between-group variation and within-group variation, allowing researchers to assess the significance of treatment effects. Non-parametric statistics are used when data do not meet the assumptions of traditional parametric tests, such as normality or homogeneity of variance. Non-parametric tests, including the Wilcoxon-Signed-Rank test, Mann-Whitney-U test, and Kruskal-Wallis test, make fewer assumptions about the underlying distribution of data and are robust to outliers. These tests are suitable for analyzing ordinal or non-normally distributed data and provide alternatives to parametric methods in such cases. Time series analysis involves studying the patterns and trends in sequential data collected over time. It encompasses techniques for modeling, forecasting, and interpreting time-dependent data, such as stock prices, temperature readings, and economic indicators. Time series models, including autoregressive integrated moving average, ARIMA, models, and exponential smoothing methods, capture underlying patterns and seasonality in the data to make accurate predictions of future values. Time series analysis is widely used in finance, economics, meteorology, and other fields to forecast trends and make informed decisions. Multivariate analysis examines the relationships between multiple variables simultaneously to uncover underlying patterns or structures in the data. Factor analysis identifies latent factors or constructs that explain the correlations among observed variables. It is used to reduce the dimensionality of data and identify underlying dimensions or constructs. Cluster analysis groups similar objects or individuals into clusters based on their characteristics or attributes. It is useful for segmentation, classification, and pattern recognition in diverse fields such as marketing, psychology, and biology. Survival analysis is a statistical technique used to analyze time-to-event data, such as time until death, failure, or occurrence of an event of interest. It accounts for censoring, where some individuals are not followed until the event of interest occurs, and models the probability of survival over time. Kaplan-Meier estimator and Cox proportional hazards model are common survival analysis methods used to estimate survival curves and assess the effects of covariates on survival outcomes. Survival analysis is widely applied in medical research, engineering, and social sciences to study time-dependent phenomena. Spatial statistics examines the distribution and spatial relationships of geographic features or phenomena. It encompasses techniques for analyzing spatial patterns, clustering, and spatial autocorrelation in spatially referenced data. Spatial interpolation methods, such as Kriging and inverse distance weighting, estimate values at unobserved locations based on nearby observations. Spatial autocorrelation measures the degree of similarity between neighboring locations and helps identify spatial patterns or clusters. Spatial statistics is used in environmental science, urban planning, epidemiology, and other disciplines to analyze geographical data and inform decision-making. Statistical quality control, SQC, is a set of tools and techniques used to monitor, control, and improve the quality of processes and products. It involves statistical methods for sampling, inspection, and process monitoring to identify and correct sources of variation. Control charts, such as the Shewhart control chart and the cumulative sum (CUSUM) chart, are used to detect shifts or trends in process performance over time. Six Sigma methodology, based on statistical process control principles, aims to reduce defects and improve process efficiency and quality. Statistical quality control is widely applied in manufacturing, healthcare, and service industries to ensure consistent and reliable outcomes. Big data analytics involves processing, analyzing, and extracting insights from large and complex datasets that exceed the capacity of traditional data processing tools. It encompasses techniques for data storage, retrieval, and analysis, as well as machine learning algorithms for predictive modeling and pattern recognition. Technologies such as Hadoop, Spark, and NoSQL databases enable distributed processing of massive datasets across clusters of computers. Data mining techniques, including association rule mining and clustering, uncover hidden patterns and relationships in big data. Big data analytics is used in diverse domains, including business intelligence, healthcare informatics, and social media analysis, to extract actionable insights and drive decision-making. Stay tuned with Essay Tips for more science videos.